All right, hello once again. This is Mr. Underkoffler, and today I'm going to be talking about squares and square roots. You can follow along with me as I read here from the guided notes. We'll start with the vocabulary word perfect square. What does that mean? Well, a perfect square is anything that comes from something being squared or something being taken to the second power. For example, 16 is a perfect square. Why? Because it comes from 4 squared, 4 to the second power. And so any number that comes from something being taken to the second power, something being squared, that answer, in this case 16, is an example of a perfect square. What I've given for you here is a nice big table showing you different perfect squares. For example, 25 is a perfect square because it comes from 5 squared. 196 is a perfect square because it comes from 14 squared. You're going to use this chart to help you on today's guided notes problem. So those of you who did not print out the guided notes, if you need to quickly handwrite down this chart of perfect squares, hit pause on the video. Make sure you do that. Those of you who do have the guided notes typed up or printed out for you, you already have this chart. Make sure you use it throughout today's guided notes problems. All right, let's continue on. Square root. I'm here in the box on your guided notes. Square root. What is square root? It is the inverse of taking a numbered squared. The symbol for square root is this looking symbol, and it is also called the radical sign. For example, 7 to the second power equals 49. Therefore, the square root of 49 would equal the 7. So this is why square root is considered the inverse of taking a number to the second power. That's what square root does. And you're going to use the chart that I was just showing you in order to do the following problems. For example, let me go ahead and do 1, 2, 3, 4, and 5 with you. Now, these problems are already typed up for you on your guided notes, but those of you who do not have the guided notes typed up for you or printed out, follow along with me as I do 1 through 5 with you. Problem number 1 is asking us to find the square root of 64. Now, how do I do that? I ask myself, what number squared would equal 64? What number to the second power would equal 64? And I can look at my chart here. I can find 64, and I can see 8 to the second power would equal 64. So the root number that if you squared it would equal 64 would be 8. So the square root of 64 equals 8. That is the answer to this square root problem. Let's do number 2. What number to the second power would equal 121? Because I have to find the square root of 121. You can go back to your chart, find the 121, see that it comes from 11 to the second power. And therefore, the square root of 121 is 11. Problem number 3, we have a negative sign outside of the square root symbol, and then we have the square root of 361. Let's start with the square root. What is the square root of 361? Well, it is 19. Why? Again, you can look back at the chart. 19 squared would equal 361. Therefore, the square root of 361 is 19. But since there's a negative sign that was outside of the square root symbol, that negative sign gets dropped down and stays to the left of the 19. So this answer to this problem is negative 19. Problem number 4. Now we're getting a little trickier on you here. We're throwing decimals in the mix. We have 25 hundredths, 0.25, and we have the square root of that. So how do I do that? Well, you might recognize the 25. I have it highlighted for you here on the chart. Comes from 5 to the second power. So you should initially be thinking 5. But is it 5 tenths or is it 5 hundredths? Well, think about this with me. Second power means times itself. Tenths times tenths would make hundredths. And so the square root of 25 hundredths is just 5 tenths. I'll say that again. Tenths times tenths would make hundredths. So that's why the answer is 5 tenths, not 5 hundredths. Because if it was 5 hundredths, 0.05, then you would have hundreds times thousands. Sorry, hundreds times hundreds. That would make 10 thousandths. And this was not 25 thousandths or 10 thousandths. This was 25 hundredths. So it should just, square root should just be 5 tenths. Likewise, problem number 5, we have the square root of 4.41, and we have a positive negative symbol to the left of it. Whenever you see this plus over a minus, that means positive or negative of the number that comes next. Now, 441, the square root of that would be 21, but since this is 4.41, the square root of that would be 2.1. The positive negative symbol would stay out in front of it. Honestly, I don't even remember if I had 441 on your list. No, I did not. So be thankful I did that problem for you, because that one was not on your list. All right, now I want you to do 6, 7, 8, 9, and 10 by yourself. So hit pause on the video, do those next 5 problems on your own, then hit play when you're ready for me to go over the answers. All right, I hope you've done that. I hope you've done 6 through 10 on your own. Let's see how you did. Problem number 6, the square root of 36 would be 6. Problem number 7, the square root of 289 would be 17. Because as you looked in the chart, 17 to the second power gives you 289. That's why the square root of 289 is 17. Problem number 8 is kind of like problem number 3 where the negative is supposed to be in front. So this becomes negative 14. Problem number 9 is kind of like problem number 4. Yes, I was a little predictable here on how I set up these problems for you. You're welcome, if that helped. This should be 7/10ths, not 700ths, not 0.07. Like I said before, tenths times tenths would make the hundredths, the 4900ths. So this should be 7/10ths. All right, problem number 10. Did you keep the positive negative sign to the left of your answer? It should be positive or negative 4 hundredths. Now why? Hundredths times hundredths would make 10 thousandths. And this was 16 10,000ths. If you count with me, tenths, hundredths, thousands, 10,000. So that's 6 is in the 10,000ths place. And hundreds times hundreds makes 10,000ths. That's why it should be positive or negative 4 hundredths. All right, let's switch it up a little bit. New directions. Estimate each square root to the nearest integer. You've noticed I keep showing you in your guided notes here that we are not supposed to be using a calculator for these problems. Instead, you're going to use the chart that I gave you earlier. So, problem number 11. Can you find the number from the chart that would be close to the 140 that is inside of the square root symbol? What perfect square is closest to the 140? Well, if you go to your chart, you will see that 144 is a perfect square, and it's definitely very close to 140. In fact, it's closer to 140 than any of the other numbers that were perfect squares on the chart. 144 is the closest to 140. Therefore, that's the number we want to use. We want to find a perfect square that we could then square root to give us an integer answer. You did notice how the directions said integer. Integer means whole numbers or their negative counterparts. That's what integers mean, for those of you who forgot what that word means. And so now we can find an integer that would be a good estimate for the original problem, the square root of 140. And that would be 12, because the square root of 144 is 12. And since 144 was close to 140, then 12 is a good integer estimate for the square root of 140. That's how we are doing these problems. If you want me to do one more with you, then follow along as I do number 12. If you instead feel like you're good to go and do 12 through 15 on your own, then fine, do 12 through 15 on your own. But I'm going to quickly talk about number 12. What perfect square is closest to 80 from our list? It is 81. And the square root of 81 would give you 9. Therefore, 9 is the best integer estimate for the square root of 80. All right, if you have not done 13 through 15 on your own, make sure you hit pause on the video right now, do those problems on your own, and then I will go over them once you hit play. All right, I hope you have already done 13 through 15 on your own. You already hit pause. I'm now going to go over these problems, see how you did. Number 13, the best perfect square closest to 200 would be 196. So the square root of 196 would give you an integer estimate of 14. Problem number 14, we have the square root of 25. The closest perfect square to 24 is 25. Actually, I think I accidentally said 25 when I was reading number 14 out loud. My apologies. And the square root of 25 would be 5, so that's the best integer estimate. And number 15, we have the square root of 350. What perfect square is closest to 350? It would be 361. So the square root of 361 would give you 19. Therefore, 19 is the best integer estimate that we can get for the square root of 350. Now, there's one more thing I want to talk about, and this kind of relates to problems number 3 and 8 that had the negative sign outside of the square root symbol. Follow along with me. What if there's a square root of a negative, meaning the negative is inside of the square root symbol? Then what would that do? Well, that would mean that you have to figure out what number taken to the second power equals negative 16. That has no real solution. That has no real answer. Why? Think about this. Because every real number taken to the second power must equal a positive. Here, I'll prove it to you. Negative 4 to the second power would mean negative 4 times negative 4. Guys, you remember a negative times a negative equals a positive. So, could there be a number times itself that could equal a negative? No. That's why if you ever have a square root of a negative, the answer to that is, well, there is no real answer. No real solution. In fact, if you would use a calculator, even though I've been telling you not to use the calculator so far in these guided notes, if you would try to punch the square root of negative 16 in your calculator, you would get an error message because your calculator knows there's no real answer to problems where you're taking the square root of a negative. All right, so I just wanted to teach that to you just in case you ever had a problem like that in the future. All right, moving on. Here's a little bit more of a challenge problem for you. I want you to do this on your own. So hit pause on the video, do number 16 on your own. All right, I hope you've done this on your own. I'm now going to go over for you. It says, which point on the number line best represents the square root of 300? You do not need a calculator for this. You can explain how you know by using the chart that I have given you before. Which number on this chart is the closest perfect square to the square root of, or to 300? That would be 289, which the square root of that would be 17. So when I look at this problem, I need something that would be just a little bit higher than 17, because this is the square root of 300, which is a little bit bigger than the square root of 289. Which choice is the best choice? It would be choice B, because this is something like 17.3 or something like that, and that's a little bit higher than 17 because 300 is a little bit higher than 289, and the square root of 289 is 17. And so that's what you should have explained. The answer is choice B. The square root of 300 is closer to the square root of 289 than it would be to the square root of 324. Therefore, it should be close to 17 for that answer, since 17 squared is 289. That's why choice B is the best answer, not choice C. Choice C is close, but choice B is the better answer in this situation. All right, let's move on to the last page of your guided notes, where we are going to talk about cubes and cube roots. A perfect cube is kind of like a perfect square, except that this time it comes from anything taken to the third power, which is we can pronounce that by saying cubed. For example, 64 is a perfect cube. Why? Because it comes from 4 cubed. It comes from 4 to the third power. Therefore, we call 64 a perfect cube. Now, I've given you a chart of the first 10 perfect cubes. For example, 729 is a perfect cube because it comes from 9 cubed. It comes from 9 to the third power. You are going to need to use these 10 perfect cubes, either memorize them, or if you don't have the guided notes typed up and printed out for you, then quickly write these down for you to help you on the next set of problems. These are the first 10 perfect cubes. All right, here we go. Before I get through 1 through 5, let's talk about cube root. Cube root is kind of like square root. It's the inverse of taking a number cubed. And the symbol for it is kind of like the square root symbol, except you have this 3 on the corner of what would have normally been the square root symbol. So this is the symbol for cube root. So quick example. Since 7 to the third power equals 343, then the cube root of 343 would equal the 7. So likewise, let's do problem number 1 together. What would be the cube root of 512? Well, you can use the chart that I've given you to help you. 512 comes from 8 to the 3rd power. Therefore, the cube root of 512 would be 8. All right, I want you to do 2, 3, 4, and 5 by yourself. So hit pause on the video. Do those 4 problems, 2 through 5, on your own. Then hit play when you're ready for me to go over the answers. Okay, I hope you've done 2 through 5 on your own. Here I go, going over the answers with you. Problem number 2, we have the cube root of 27. That would be the answer of 3. Problem number 3, did you keep the negative sign to the left of your answer? Because this is the negative of the cube root of 125. The cube root of 125 would be 5. Therefore, the answer to number 3 is negative 5. Now, problem number 4. This was a slightly tricky problem. You might have remembered how I just got done teaching you that if you have the square root of a negative, then there's no real solution because there's nothing times itself that could equal a negative. A negative times a negative would equal a positive. But having said that, problem number 4, since it's the cube root of a negative, what happens if you take a negative times a negative times a 3rd negative? You actually get a negative answer. So if you thought number 4 had no solution, you are wrong. It is negative 5. Think about this. Negative 5 times negative 5 is positive 25. But if I take positive 25 times another negative 5, I'm back to a negative number. So an odd amount of negative numbers multiplied to each other gives you a negative answer. Therefore, the cube root of a negative can be done, and it equals a negative answer. So that was a trick problem. If you got number 4 wrong, don't lose sleep over it. But that's why the answer is a negative answer. And if you don't understand what I just said, hit rewind on the video, listen to my explanation again, and hopefully you'll get what I'm trying to explain to you. All right, problem number 5. We have the positive or the negative of the cube root of 0.729. Well, you should have recognized 729. That is a perfect cube, comes from 9 to the 3rd power. Therefore, this should be positive or negative, just keep that symbol in front, 0.9. All right, problems 6 through 9. The directions say to estimate each cube root to the nearest integer. Remember, integers mean whole numbers or their negative counterparts. So we are looking for the closest whole number answer that we are going to estimate for each of these problems. I'll do number 6 with you in case you need me to. It says the cube root of 10. Now, what perfect cube is closest to 10? Go to your chart. The closest perfect cube to 10 is 8. If you accidentally thought it was going to be 9, you're accidentally thinking perfect squares. We're doing cubes here, okay? So the closest perfect cube to 10 would be 8, and that comes from 2 to the 3rd power. And so that's what we're going to use for problem number 6. We're going to say this is close to being the cube root of 8. And the cube root of 8 would be 2. Therefore, the closest integer estimate for the cube root of 10 is 2. All right, now that I've done problem number 6 with you, try 7, 8, and 9 on your own. You can also do number 10 on your own if you have the guided notes typed up for you. So hit pause, do those problems on your own, then hit play when you're ready for me to go over the answers. Okay, I hope you've done these problems on your own. Here I go going over the answers. Problem number 7. Cube root of 990, and we are looking for the closest integer estimate to this problem. Well, the closest perfect cube to 990 was 1,000. And the cube root of 1,000 would be 10. Therefore, that's the best integer estimate for problem number 7. Problem number 8. What perfect cube is closest to 30? It was 27. So the cube root of 27 would give you an integer estimate of 3. And problem number 9. What perfect cube is closest to 711? If you went to the chart, you probably saw the closest choice was 729. And so that's what we're going to use here. This is close to being the cube root of 729. Therefore, the best integer estimate is 9. All right, last problem of the guided notes, problem number 10. If you have not done this problem yet on your own, please hit pause on the video, do this problem on your own, then hit play when you're ready for me to go over the answer. Okay, I hope you've done this problem on your own. Let's see how you did. It says, which point on the number line best represents the cube root of 200? So, did you go to your chart and look to see what perfect cube was closest to 200? If I go to my chart, I can see the closest perfect cube to 200 is 216. And the cube root of 216 is 6. So, I'm looking for something, since 200 is a little bit lower than 216, I'm looking for something that's a little bit smaller than 6. That looks like choice B. So, did you say that was your answer, and did you follow the directions? The directions said explain how you know. You need to explain. This is not optional. You have to explain. So hopefully you gave an explanation similar to what I gave. It doesn't have to be exactly the same, but similar. The cube root of 200 is closer to the cube root of 216 than it would be to the cube root of 125. I mean, 200 is definitely closer to 216 than it is to 125. Therefore, it should be close to 6 because 6 to the third power would equal 216. That's why this answer should be a little bit lower than 6. And that's why it's choice B. All right, guys, that's the guided notes on squares and square roots and also cubes and cube roots. We will see you next time.